Hello everybody and welcome back to Unit 1 of Regents Chemistry, which is a math of chemistry. Today we will be learning about the dimensional analysis. So, have you ever tried to convert your weight from pounds to kilograms? Or your height from feet to inches? Because if you have, you have performed unit conversion. So let's quickly look at how you might have done it. So if I ask you how many inches do we have in 5 feet, what you will most likely do is you will know or you'll try to find out that 1 feet has 12 inches, right? And then you'll just take your 5 feet and you'll multiply that with 12 inches, and you'll get your answer 60 inches, and you'll just tell me that 5 feet has 60 inches. Now, when we do this thing in chemistry, it's kind of similar, but there are just a couple things that we add in there. And those couple of things are, let's say I am asking you the same question. How many inches do we have in 5 feet? You will still try to figure out that 1 feet has 12 inches. And this is going to be our conversion factor. A conversion factor is basically a ratio that relates two different units that express the same quantity. So for example, the feet and inches both represent length. But this conversion factor is relating the feet and the inches by telling us that 1 feet has 12 inches. Now, what we do with this conversion factor when we try to solve this problem in terms of chemistry is we take our 5 feet and we multiply that with this conversion factor. Now, when we are doing that, we want to put one of these two things on the top and the other thing at the bottom. So either the 1 feet will go at the top or the 12 inches will go at the top. So how do we figure out what do we need to put at the top of this ratio? Think about what are you looking for in the question. Now, because the question is asking us to find how many inches, we are going to go ahead and put the 12 inches on the top and then 1 feet at the bottom. Now, what this does is that it will cancel the unit feet with the feet. And now we'll just do the simple math. 5 times 12, which is 60, divided by 1. And that gives us 60 inches because inches is the only unit that's left in there now. We don't have any feet left to take care of. We already canceled them. Okay, so that's how we do the dimensional analysis. Same procedure, just a couple things to take care of. So let's quickly review some of the rules that we want to make sure we know and we follow whenever we are performing dimensional analysis. The first thing that we want to do is determine the conversion factor. That's a must. Second, we multiply our conversion factor with whatever number we are given in the question. And when we do that, we want to make sure that we place the unit that we need on the top. So whatever the question is asking for. So for example, in the previous question, we were looking for the inches. So we had to place the inches on the top and then the other one at the bottom. And the reason why we are putting the other one at the bottom is just so we can cancel our units. And then we do the simple math and get our answer in the desired unit. Okay, so you guys will be using table C and D, which are on page 1 in your reference table packet to figure out some of your conversion factors. So you will need to know some of the prefixes, and we will be combining these prefixes with some of the units. So that's why you will be coming back to these tables to work on some questions. So let me ask you, how many meters do we have in 2 millimeter? The first thing that you want to do here is figure out your conversion factor. So we start with, well, what is a millimeter? So we know that this is the prefix milli combined with a meter. So you find the prefix milli in table C in your reference table packet, which is on page 1. And turns out that milli is 10 to the power of negative 3. So 1 millimeter is basically equal to 10 to the power of negative 3 meters. All I did here was I substituted the milli with 10 to the power of negative 3. So substitute means just putting something in the place of the other thing. So rather than putting m, which represents milli, I have now put 10 to the power of negative 3. Now when we convert this 10 to the power of negative 3 into a regular number, like I break down the scientific notation form and convert that to a regular form, says that we have an exponent of -3, so we start with a 1, and right now 1 has a decimal right there at the very end. So -3 means we have to move our decimal 3 times to the left. So 1, 2, 3. And then remember, we have to put the zeros in the middle. So 1 millimeter is basically equal to 10 to the power of, 1 millimeter is basically equal to 0.001 meters. And that is our conversion factor. Now we can take the number that's given in the question, which is 2 millimeter, and we have to multiply that with our conversion factor. But now we want to figure out which thing do we want to put on the top and what do we want to put at the bottom. So look at the question. The question is asking for how many meters do we have in 2 millimeters. So we want our answer to be in meters, which means we will put the 0.001 meters at the top and we'll put 1 millimeter at the bottom. So the millimeter can cancel out with the millimeter, and then we just do the math. 2 times 0.001 divided by 1, we get 2.001 meters. That's how many meters we have in 2 millimeters. Okay, next question. How many grams do we have in 3.5 kilograms? Once again, first thing that we want to do is figure out the conversion factor. So we look at the prefix, or we look at the kilogram. The prefix in there is kilo. We try to find that from the table C. Turns out kilo is 10 to the power of 3. We can just go ahead and substitute the kilo with 10 to the power of 3. Now we have to convert this into a regular number. So remember, it's a positive 3 exponent. We start with 1 and then we move our decimal 3 times to the right because it's a positive number. It's a positive exponent. So 1 kilogram is equal to 1,000 gram. That is our conversion factor. Now we take the 3.5 kilograms, which is what the question has given us. We have to multiply that with our conversion factor. What did we put on the top this time? Remember, the question is asking us to find out grams. We want our answer in grams. So we'll put 1,000 grams on the top, and we want to get rid of the kilograms, so that's what goes at the bottom. The kilograms cancel with the kilograms, and we just do the math. 3.5 times 1,000 divided by 1. Our answer is going to be 3,500 grams. Next up, how many centimeters do we have in 95.38 meters? Once again, we want to figure out the conversion factor first. So we look at the centimeter, try to find the prefix centi from table C. And that turns out to be 10 to the power of -2. So 1 centimeter is 10 to the power of -2 meters. Now we want to convert this into a regular number. So once again, we start with 1. And we move our decimal 2 times to the left because it's a negative number. So that gives us a conversion factor of 1 centimeter equals 0.001 meters. Now we take our number 95.38 meters, we multiply that with our conversion factor. What do we put on the top? What do we put at the bottom? Well, we want our answer in centimeters, so we'll put 1 centimeter at the top and we'll put 0.01 meters at the bottom. The meter is going to cancel out with the meter, and we are going to do the normal math. 95.38 times 1, which is 95.38, divided by 0.01. Our answer is 9,538 centimeters. That's how many centimeters we have in 95.38 meters. Okay, so that was it for this part of the unit. Happy learning, and I will see you guys in the next one.